Hello class, this is Mr. Hart, and in this video I want to go over the graphing assignment. A lot of students had questions on how to complete the assignment because they hadn't maybe done these specific types of graphs before, so I just want to make sure everyone feels comfortable how to do them, so I'm going to go through these graphs with you. Okay, we're going to go through each problem together. Okay, so what I'm going to do is I'm going to, shift this over so we can see the problems, and then I'm going to do the graphs over on this side. Okay, so let's look at problem number one. So Mr. Miller spends his summer working for the mosquito abatement department for the county. One of his jobs is to report on the total number of mosquitoes trapped during the year. Below is the data he collected over the past decade. Okay, so we have number of mosquitoes caught in Utah County per year, and this is the year, and this is the number right there. Okay, all the way up to 2014. So the first question we need to ask ourselves is, what kind of graph do we want? Okay, we have each year listed out and just stats of how much mosquitoes were caught that year. Okay, so there's a couple ones you could do. You could do this as a line graph, just comparing year versus mosquitoes caught. You could also do it as a bar graph, each year being a bar and the total mosquitoes caught being associated for the height of the bar. So it turns out they're pretty much the same when it comes to designing the graph. So we'll go ahead and do a bar graph. I'll show you how you could have also made a line graph. Okay, so let me go ahead. I'm going to grab my whiteboard app, put that to the side. Okay, so on this one, let's start by making our axes here. Okay, and because this goes from 2005 to 2014, we'll just make one axis mark for each year. Okay, we'll have 10 marks. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 2005. Sorry, it's hard to write sideways. 2006, 2007, so on, until we get to 2014. Okay, so that's our years. Okay, so we're plotting a year down here, and then we're comparing to mosquitoes caught up here. And so what we need to do is look at our data, and we need to determine the kind of the lowest number caught and the highest number caught. So if you look at all those, it looks like our lowest is about 20,000, and our highest is about 200,000. Okay, so we need marks that go between 20,000 and 200,000. Okay, so if we want about 10 marks, that's about 20,000 each. Okay, so let's do 20,000, 40,000, 60,000, 80,000, 100,000, 120,000, 140,000, 160,000, 180,000, 200,000, 220,000. Okay, so 20,000, 40,000, 60,000, and you don't have to mark all these. You can. It generally works if you just mark one or two, and you should be fine. Actually, sorry, you should at least mark two, and maybe a few more after that. But I'm going to go ahead and mark all of these just so it's easier to see. All right, almost there. Okay. All right, so now we have our markings, so all we got to do is plot the data. Okay, so in 2005, we are at around 80,000. So I'm going to go to 2005 on the x-axis down here and go up to to 80,000. So that's going to be around right there. Let me go ahead actually and change colors here. So again, I go over to 2005 on the x-axis up to about 80,000. Okay, that puts my point around right there. Okay, 2006 we're at 50,000. Okay, so again, go to 2006 on the x-axis. 50,000 is around between 40,000 and 60,000. So I'm going to put that right there. 2007, we're at 42,000, so that's just a little bit lower, around there. 2008, we're at, again, around 42,000, so just even a little bit lower than that right there. 2009, we go even lower, around 39,000, so that's even just a little bit lower around there. 2010, let's see, yep, 2010, we're at 24,000. So that's just going to be above the 20,000 mark at 2010. Then we jump all the way up to 200,000, 220,000 essentially. So we're going to go all the way up here to 210,000. Okay. Then we're back to around 90,000. So again, we'll go over to this on the x-axis and then go up to about 90,000, which is about here. And I apologize, it's not showing my cursor within the graph for some reason. And then 2013, we're at 42,000. So we'll go back to 2013, around 42,000 around right there. And then last of all, 2014 is all the way down at 20,000. So we'll go back down to about right there. Okay. So again, it's plotting coordinates just like you do in math class. What is my x-axis value? What is my y-axis value? You put them in. Okay. So if you want to do this as a line graph, all you do is basically connect the dots. So connect that, jump up to there, connect that, down there. Okay, so you can see that there was a negative trend. It jumped up in 2011, and then it goes back down. Okay. If you want to make this a bar graph, all you got to do is, instead of doing lines, you basically just do bars for those values. Okay. So there's 2005, 2006, 2007, 2008, 2009, 2010, then all the way up here for 2011, 2012, 2013, 2014. Okay. Sorry, I can't draw straight lines, but that is what you would do for a bar graph. Okay. So I'd say either one's valid in this case. And you can do either one of those. But the main thing is that you get the points drawn on the graph so you can see this downward trend jumps up and then downward again. Okay. All right. Let's do our next one. I'm still learning how to clear the graph. There we go. All right, here's our next one. So data set 2. So during a lab, a student has a beaker of water over a Bunsen burner. During the process, she collected the water's temperature at regular time intervals. Her collected data is below. Okay, so this is the temperature in Celsius and the time in seconds. Okay, so the first question is, what kind of graph should we use? Again, if it is a controlled experiment like this, we probably should use a line graph. Very clear. This is time, this is temperature, etc. Okay, cause and effect. Next question is, which one's the independent variable, which one's the dependent variable? Okay, well, they waited a certain amount of time before taking each measurement, so the time is actually our independent variable and the temperature is our dependent variable. Okay, so let's set up our graph as so. Time is our independent variable, so we'll make sure to put it on the x-axis, and temperature is our dependent variable, so we'll put it on the y-axis. Okay, it also never hurts to put the units you're using. So we're doing time in seconds and temperature in degrees Celsius. Okay, so marking that with parentheses is often good practice. Okay, so now we need to figure out our markings. So time goes from 0 to 180, and all these are already split by 30, so it's nice and evenly spaced, so let's just use that. So we got 0, 30, 60, 90, 120, 150, 180. Okay. And then on our y-axis, again, they happen to be already split up by 5, so we'll just use those. So we got 10, 15, 20, 25, 30, 35, 40. Okay? Now we go and plot the points. Okay, so at time equals 0, we're at 10. So we go over to 0, up to 10, we'll put a point right there. Then at time equals 30, we're at 15. So we go over to 30, up to 15, put a point right there. 60, 20, so we'll go over to 60, up to 20, put a point right there. 90, 25, over to 90, up to 25, right there. 120, 30, so we'll put a point right there. 150, 35, put a point right there. 180 and 40, so we'll put a point right there. Okay, so line graphs aren't always a straight line, but this one actually happens to be exactly a straight line. Okay, hopefully that's pretty straightforward. Okay, so that's graph number 2. Okay, let's do our last one. So data set 3, below is represented height and weight of data for a group of American teenagers. So you have this big long list of height and weight. Okay, so I'm going to actually move my screen like this a little bit so we can see those better. So it's height in inches, weight in pounds. Okay, so a bunch of just gathered data. So the first question is, what kind of graph should we make if we're just given kind of random data and we're looking for correlations? Okay, well, hopefully we should use a scatter plot. Okay, so we're going to set up a scatter plot. The next question we need to ask is, do we use, which one do we put on x-axis and which one do we put on y-axis? Turns out it doesn't matter generally in a scatter plot because we're not using cause and effect, right? One's not dependent necessarily on the other. We're just looking for trends and patterns. Okay, so I'm just going to go ahead and put the height on this axis and the weight on this axis. Okay, so here's the weight in pounds. Here's the height in inches. Okay, so now what we need to do is we need to look at the height and find the lowest and highest value. Okay, so if we go through that list, it looks like the lowest value is this 65.78 and the highest value is this 71.52. So we need to go from about 65 to about 72. So let's go ahead and just go by ones. So this will be 65, 66, 67, 68, 69, 70, 71, 72. Okay, now we need to do the same thing for weight. What's our lowest value? What's our highest value? So if we're looking at the weight, our lowest value is this 112.37, and our highest value I think is this 153 right here. Okay, so we need to go from about 110 to about 155. So let's go ahead and go by fives. Okay, so this will be 110, 115, 120, 125, 130, 135, 140, 145, 150, 155. Okay. All right, so we have our axes. Now we're ready to plot. So the first one, 65.78 and 112.99. Okay, so that will be just above 65 and below 66. Sorry, that was not an actual point right there. So just above 65 and above, or just above 65, below 66, and at around 112. So that's going to be around right there. Okay. 71.52 and 136.49. Okay, so 71.52 will be all the way over to the right, and 136.9 will be just above 135. So 71.52 on the x-axis, and the y-axis would be about right there. Okay, 71.5 over 136.5 up. 69.4, 153.03. So we're just going to go just below 70, or just above 69, and we'll go just below 155. So that'll be all the way up here. Okay. 68.22, 142.34. So 68.22 will just be right above 68 on the x-axis and right above 140 on the y. So that will put us around right there. Okay, 67.79, 144. So that will just be just to the left, around right there. 68.70, 123.30. So 68.70, that is above 68, and 123.0 is just below 125, so that's around right there. Okay. 69.80, 141.49, so that's right around 70 and right below 142 or 145, so go right around 70. We're talking around right there. Okay. 70 and 136. So that's going to be around there. Over to 70, right below, right above 135. 67.9. So that's right around 68 and 112. So that's going to be right around there. So right around 68 in the x-axis and right around 115 in the y-axis. And then 66.78 at 120. So 66.78 would be between 66 and 67. And around 120, so that'll put us right around there. And then finally 66.5 and 127.5-ish. So that will be right above 66 again and right above 125. So around there. Okay? So even though there's not a clear line, there still is a clear trend that as you get taller, you generally weigh more, right? Which makes sense, that you're just generally bigger if you generally are taller. Okay, there you go. Those are our 3 graphs. Okay, so the key for designing any graph is, first of all, just make sure you know what type of graph you want to make. Figure out what you want on the x-axis, figure out what you want on the y-axis, and then figure out kind of the domain or range you need to cover, basically what numbers you're going to put for the x and y-axis, and then plot the actual data. Okay, so those are kind of the 4 steps. Okay, but hopefully that was helpful, and obviously following along you should be able to turn in your homework, given that those are the 3 graphs on your homework. Okay, let me know if you have any questions, and thank you for watching.